Welcome to this video lecture, Week 7 Parallel Exercise Walkthrough. Our objective for Exercise 1 focuses on mastery of the upper function. Our first exercise parallels TAL number 1 for this assignment set. And TAL number 1 says list the item number and description for all items, but the descriptions should appear in uppercase letters. So let's start with a fundamental query, just a basic select query as we're familiar with. And here we've selected the item number description from the item table. But we need to do one additional thing, and that is we need to make sure that the description is set in all uppercase. And for that, we can use a string function, upper, and that will shift all the contents of that field to uppercase. And so if you observe right now, we have mixed case. When we run it with the upper function, all of the output is shifted to uppercase, and we are good to go. Exercise 2 will acquaint us with the round function. Our second exercise will parallel TAL number 3, which says list the customer number, name, and balance for all customers. And the twist here is that the balance should be rounded to the nearest dollar. So let's start with just the basic query. Select customer number, customer name, balance from customer. And what we need to do here is round the balance to the nearest dollar, so 0 decimal places of rounding. And for that, we can simply take and apply the round function on the balance with 0 decimal places being included. And so that'll round to the nearest whole dollar. And if we execute that, we see that it has indeed. And just to prove that it's rounded, let's drop that back out for a second. Matter of fact, let's put them right next to each other and compare them. Okay, so here we have 12, 10, 25 rounds down, 23, 45, 75 rounds up. So we are seeing the behavior that we would expect for correct rounding, as opposed to other kinds of rounding, bankers rounding and other kinds of rounding, or truncating or flooring. So this is true rounding, and that appears to be working correctly. So I'll go ahead and drop the alias on that and turn it back to just the whole solution. And there's the solution per specification, just the customer number, customer name, and the rounded balance. And I don't think it said to specify the name. So since this is essentially a calculated field, it's saying there's no column name. If you want, you could go ahead and turn that back to its original name by just saying balance as balance, and the label will be applied. There you are. In exercise 3, we will explore the date add function. Our third exercise uses TAL4 as a parallel, and it states TAL Distributors is running a promotion that is valid for up to 20 days after an order is placed. List the order number, customer name, and promotion date for each order. The promotion date is 20 days after the order was placed. So again, let's start with the basic query. So we'll give it the order number, customer name, order date from orders, customers joined on customer number between orders and customer. And then what we're going to need to do is play with the order date to get a little bit of date arithmetic. But let's start with the basics and make sure they're running correctly. All right, so here's the basic query. And then let's go ahead and temporarily add in an extra field, which will be our calculated field, just so that we can compare it and eyeball it and make sure it's correct. And once we've got it working correctly, we'll eliminate the redundant field. So what we want to do here is we want to use the date add function, and we're going to use it on the day operator. We're adding 20 days to the order date, and we're going to alias this as promotion date. Okay, and let's run that. And then let's sanity check this. So October 12th plus 20 days becomes November the 1st. That seems to be right. And let's grab another one down here. October the 16th plus 20 days, November the 5th. That again seems right. So it looks like our date math is working correctly. And now let's go ahead and eliminate the redundant order date, so we're just meeting the exact criteria, and there's our solution. Okay, so if there's a date add, a lot of students ask, is there a date subtract? Well, why do you need to subtract when you can add negative numbers? We could also go the other direction just as easily. So same function, date add, suffices for both, and we can play with day or month or other keyword operators. You can look up the reference for the date add function in Transaxial and find out all the nifty different keywords that can be used here. Our key objective for exercise 4 is to create a simple parameterized stored procedure which will select records based on a single input parameter. In exercise 4, we're going to write our first Transaxial stored procedure, and this is going to be based off of the parallel exercise TAL 5 Part A, which says write a T-SQL procedure to obtain the name and credit limit of the customer number whose number currently is stored in I underscore customer underscore num. Place these values in the variables I underscore customer underscore name and I underscore credit underscore limit respectively. Output the contents of the I customer name and I credit limit. Okay, now this is actually very poorly worded for Transaxial. This would be the way you would outline this problem for PL/SQL, which is used in Oracle database. I think we should probably make a couple changes to this problem statement to make it a little bit clearer. So um, input and output parameters are commonly identified this way with the I underscore this or O underscore that kind of thing in PL/SQL. Transaxial uses a little bit different approach. So this is going to take one input parameter. Everything else is going to be returned simply as the output of a select query. Okay, so when it says the customer number is in I underscore customer underscore num, let's use the parameter at custnum. And as far as place these values in the variable, let's just change this to say output this information and the fields that we want to output here are going to be the customer name and let's see, are we going to reiterate the input parameter? Yeah, no, just the credit limit. Okay, so customer name and credit limits, all we really need to output. So that will make that a little more Microsoft friendly, a little more T-SQL like. Okay, so all in the translation. And let's start before we build this as a stored procedure. Let's just build it as a select statement without a parameter, just get the basics working. So what we're looking to do is we want to select the customer name and the credit limit from customer where customer num equals something. We don't know what yet. So let's do this. I'm just going to comment out that last line. And let's do a simple select. Okay. So here's everything. Okay. Let's temporarily put the customer number back in so we can see it. There it is. And let's grab one of these at random. Let's say 440. So this is obviously not yet parameterized. We've hard-coded 440. There it is. And now let's get rid of this. So for the one particular case where our input variable would be 440 for the customer num, then this would be identical to the result. Now we need to just parameterize this and turn it into a stored procedure. Okay. So to do that, we're going to say create procedure, and let's call it user stored procedure disp cust cred. Okay, so display customer credit, and we're going to use as the parameter the variable at custnum, and let's make that a char 3. And why a char 3? Well, let's take a look at our databases and take a look at TAL, and let's take a look at the customer table. And here are the columns. Make a little more real estate here on the screen. And we see that customer num is a char 3. So that will be capable of storing a compatible value for any value that could be stored as a custom. We just made it the same data type, and so that's kind of going to be very conservative. It's going to preserve any possible value that could be stored in there, so it will be usable. And then let's see, we're going to change this select slightly and say as select custom credit limit from customer where customer number equals, and now let's change that to be replaced by this variable. So now, in order to run this stored procedure, once its stored procedure has been created, which we're going to create in just a moment, we will need to provide the custom parameter every time we run it, and it will use that parameter as the variable value that it's going to run this select query on. Okay. Before we run that, let me take a quick look at the TAL database, and let's see if I've created one of these before. So let's take a look under programmability, and in the stored procedures, and I don't see anything other than system stored procedures. That's fine. This is a user stored procedure, so I'm not seeing that it's out there. If it was, we would simply drop it so that we could recreate it, but this should create it. So let's run this and see if we've done our work correctly. Command completed successfully. So now if we were to go and refresh this database and then take a look at the programmability in our stored procedures, we now see that the database owner, that's me, has a user stored procedure disp cust cred out there. And we could further look into the parameters that are there, and we would see at custom. Okay. And very good. It returns an integer. Actually, it's going to return the query result. The integer it's going to return is simply going to indicate whether it succeeded or failed in executing. And that's not the results that we're worried about. We're going to be looking at the results of the select. So let's go ahead and invoke this. And the way that we invoke a stored procedure is with an exec command. Oops. Here we go. Exec USP cred at customer number equals 260. And let's see if there's one out there that has the value 260. And we do. Brookings Direct, and their credit limit is 10,000. So now we're in business, and we can use that stored procedure over and over again, and all of its logic could be invoked, by a program. So rather than having to have programmers code the procedure over and over, and somebody might get it wrong, or somebody might code it differently, or somebody might code it deficiently and it would have a bug in it. Now we can make use of that object out there, that program object, that stored procedure, and call it from all of our different code, including if we're making mobile code, if we're making web code, if we're making fat client code, traditional executable programs that run on a PC. Wherever we run it, we can make use of the one procedure that's stored with the database, and that means wherever we go, whatever platform we're using, whatever programming language we're using, can still make use of that stored procedure, and it'll run exactly the same way and produce the same result. Very powerful. In exercise 5, we will once again focus on creating a simple parameterized stored procedure, which will select records based on a single parameter. All right, let's take a look at exercise 5. And for exercise 5, we're using the parallel problem exercise 5B from TAL. And its original problem statement says, write a T-SQL procedure to obtain the order date, customer number, and name for the order whose number currently is stored in iOrderNum. Place these values in the variables iOrderDate, iCustomerNum, and iCustomerName respectively. Output the contents of iOrderDate, iOrderNum, and iCustomerNum. And again, this is very heavily Oracle-centric, so let's kind of modify the original problem statement, interpret it so that it has more of a Microsoft SQL Server T-SQL or Transaxial flair. And so what we're really going to do is we're going to use one input variable is all that's needed here. And again, the input variable is going to be order num. So let's see here, stored in, and let's do it SQL style or T-SQL style, which is at order num rather than the Oracle centric I_order num. And where it says place the variables for output, well, we don't have to do that in T-SQL syntax. It's just the results of the select statement. And so let's output the fields, and we're after the order date, the customer num, and the customer name. Much simpler to do in Transaxial, actually. No big deal either way. All right, so again, our strategy toward creating the stored procedure is to go ahead and write just a single select query that would work for one case, and then we'll parameterize it and convert it to a stored procedure that solves the general case. Okay, so we want to select the customer number, and no, sorry, we want the order date, the customer number. You know what, let's do? Notice that IntelliSense is not providing things for me. That's because I haven't told it what table yet. This is why it's always easier to start with select star from customer. Okay, so now that we have the table specified, we should easily be able to come back here and use IntelliSense, and that'll make typing a little bit easier. So customer name, oh, gotta love that. And oh, except I'm wrong, of course. We wanted the order date. Ah, I'm looking at 5A. We want this from orders and customer. Got to have a join on this one. Okay, start with a blown join. Okay, so we want the order date, the customer number, and that's going to be ambiguous. So let's say orders dot customer number and the customer name. Great. Now you'll be chomping at the bit to say, Beck, you've forgotten and blown this. This is going to give us a um, Cartesian product, and that's entirely right. So we better put our join criteria in here. And so where orders dot customer number equals customer dot customer number. There we go. There's the foreign key primary key foreign key relationship. And also where the orders dot order number equals something. We don't know what yet. Okay, so we can kind of comment that out for right now. And let's get a sample, run this as a select. There it is. And let's say arbitrarily we just wanted where the customer number is 334. Okay, let's come in here, uncomment that, and oh, threw an extra where in there. There we go. Oops, now I've lost everything. What did I miss? Oh, order number, not customer number. Order number. Ah, but we didn't list the order number. Ah, okay. That's okay. This is good for me to make some mistakes because these are some of the same mistakes that students are going to make. So it's helpful. Orders dot order num. We'll throw that back in temporarily. Okay, so here's one. 51610. 51610. And let's uncomment that and run it. And now it just gives us 51610. We had thrown this in temporarily. It's not part of the specification. Get rid of that. Still working. Okay, now we have a working individual query for one specific case. Now we need to parameterize it so it works for every case. So this is going to be at order num, which also means we need to come and declare this. So we need to create our stored procedure, and let's call this user stored procedure disp orders, display orders as this, but we need to declare at order num, and what should it be? Well, I think it's a char3, but let's go take a look. The way we can double check is come into tal, come down to our tables, come down to orders, look at the columns, and order num. Oh, actually, order num is actually a char5, so it should be a char5 to do that correctly. Yeah, got to check these things. And of course, it's a char5 because we just tested on a 5-digit number, so should have realized that right off the bat. Okay, So if this is now correct, and if the procedure doesn't already exist, we should be able to run this code and create it. And that executed successfully. So now we should be able to exec USP disp orders at order num equals, and let's see, I don't remember the name of a valid order number, so let's go get one right quick. And 51610 is what we were testing with. And let's run this. And there it is. Nice. Well, a couple left turns in the process, but we got there. Our exercise 6 objective is to create a simple parameterized stored procedure which will insert records. Exercise 6 is a parallel to 5C on the TAL problem set for the current chapter. And it says write a T-SQL procedure to add a row to the orders table. Okay, so we need to start with a basic insert statement, and a real easy way, as we've learned before, to script that so we don't have to write it all from scratch is to come over to the orders table and script the table as insert, and let's send that to a new query editor window. So here is our basic piece. I'm going to get rid of some of the excess, and let's simplify this just a little bit. We're going to use these values as parameters. So let's take, and instead of order num, let's make it at order num. I'll tell you, let's use the convention of all lowercase for our variables. And we don't really need to specify the data type here because that's going to be intrinsic. We will already have declared them. And let's make this at order date. And at customer num. Okay, so these are the variables that we're going to use as parameters passed in. And again, we don't need the type. And there we go. So those are going to be the actual values that are the variables or the placeholders for those values passed into our stored procedure. And then we're going to clean up this a little bit. And so it says insert into, and it's always okay to fully qualify, the database owner, and in square brackets orders. A simpler way to do it would just be, since we're running under the database owner right now, into orders. A little cleaner, a little easier to understand, I think, while we're learning. And then instead of this being order num, this is going to be at order num. And that's a char 5. Here's where we could have preserved the original data types. And this is going to be at order date. And that's going to be a date type. At customer num. And make that a char 3, I believe. And this should be our insert statement. Get rid of the go. We don't need to structure it as a batch. And I'm just going to copy that, Control C, and pop back over to our original query window. So here's our problem statement. And here's the insert statement. Okay. And with that all structured, we just need now to convert that into a stored procedure. So to do that, we will say create procedure, and let's name it USP underscore add orders. And move this down. Insert into orders. Oh, and I probably should have just saved the original fields. I'll retype them. Order num, order date, and customer num. There we go. Create procedure, USP, add orders, add order num char 5, add order date, add customer num char 3. As. There we go. And let's tidy up some of our indenting. All right, that should do it. And let's see if we run this, this should create the stored procedure. Commands completed successfully. And now we need to test that. Let's go ahead and add a row to exercise that. Okay, so let's come and select star from orders. There it is. And how about we add an order number, and let's go ahead and exec this. So we need to exec USP add orders. And notice that IntelliSense has read our definition and now is coaching us on what we need to do to provide that. So we need to provide these three variables: add order num, at order date, and at customer num, and their values. So let's say at order num equals, and let's make it 99999, and at order date equals, and let's make it a 101 2019, and then our final parameter is at customer num equals, and let's just reuse one of these customer numbers again. How about the first one? And let's make it 126. And let's see, does that do the job? Let's highlight just this and execute it. One row affected. Let's select again. And there it is. It's added our new row using the stored procedure. And now what we probably ought to do, so I don't mess up our sample data file or have to reload it, let's go ahead and run a delete on that. So delete from orders or delete orders, we could just say, where order num equals 99999. Fire that off. One row affected. Select it, and we've cleaned up after ourselves. And now we have our stored procedure, which not only, so we've got a stored procedure that can select data, we've got now one that can create new records. Our exercise 7 objective is to create a simple parameterized stored procedure to update records. All right, our exercise 7 is going to use as a parallel TAL 5 part D, and that says write a T-SQL procedure to change the date of the order whose number is stored in iOrderNum to the date currently found in iOrderDate. And as we've kind of figured out, this is very Oracle style. And so let's change these to parameter names that are more in keeping with what we'd use in T-SQL. And so let's call this just at order num, date currently found in, and let's make this at order date. Okay, so we can do a little updating here. And in general, that's going to look like this. Update orders, we want to set the order date to this variable, and we want to do that where the order number is equal to this order number. Okay, so to complete this as a stored procedure, we need to create the stored procedure. And let's create this procedure and call it USP update UPD order date. And then we need to define our variables. So we need at order num. And if you look up the data type, I think that should be a char5. And again, we use the actual definition of the fields as the best guide for what this should probably be in terms of our definition of the data type of the variable. Should match, that's best practice. And at order date, and that needs to be as. Okay. Create procedure, USP update order date at order num char5. I think I missed a comma here. At order date as update record set order date equals order date where order num equals order num, and that should be good to go. Let's execute that, and that executed successfully. And so now let's play with that a little bit. So this is going to update the order date based on the order num, okay, to whatever order date we give it. Okay, so let's go grab one and see. Yeah, so the very last one here is order num 51625. So let's go ahead and exec USP and update order date. And here again, IntelliSense is helping and prompting us. So we need to give it the order num, and let's change 51625. And let's just make a note. This used to be 215.10.16. So I'm just going to put it up here. So we'll know what to put it back to when we clean up after ourselves. And so we're going to update order date. And how about we make that order date equals, and let's make it, let's say 2019-01-01. Okay, and let's execute this. One row affected, which is what we expect. What do we now have? Select it again, and now we find that 51625 has been updated to 2019-01-01, and so that's working correctly. Now let's put it back the way we had it. Clean up after ourselves so we don't have to reload our data. And highlight just the exec and run it, and then check it, and we're back to what we were. In exercise 8, we will create a simple parameterized stored procedure to delete records based on parameterized criteria. All right, and now let's address exercise 8, and for that we're using as a parallel 5E. Write a T-SQL to delete the order whose number is stored in iOrderNum. And let's clean up our query results right quick. Just clean that up with use towel. There we go. Hadn't cleaned up from the last thing we did. All right. So this is going to be a delete query, and that's pretty simple. We want to delete from orders where the order num is equal to some variable at order num. And let's kind of clean up our original problem statement, because again, the book tends to be very Oracle centric. It's giving you an Oracle style variable name. Let's use a SQL Server style at order num. So write a T-SQL procedure to delete the order number whose number is stored in at order num. So that should be it. We just need to now structure this as a stored procedure and then go ahead and uh, declare the parameters. So let's see, this is going to be create procedure USP delete orders, and the parameter we need is just one, at order num, and order num is a char 5 as the following. And that should work. Let's go ahead and give it a shot. Okay. And so now that it's been created, we ought to test it. So let's create some garbage record that we can then delete. And so we're going to delete an order. So let's go ahead and start by select star from orders. And okay, so we just need an arbitrary order number, a date, and a customer number. We'll reuse customer number 126, let's say. Um, and here's a real quick and easy way for us to add a garbage record in there. Let's go into the orders table, right click and say edit the top 200 rows. And I don't think we've used this feature before. This gives us an editable table. And so let's make this 99999. And for the date, let's use 2019-01-01. And let's see, instead of null, let's use customer 126. And then go ahead and close this query. And now if we select that again, if our update took, and it did, here's our garbage record that we want to get rid of. And so now let's use our stored procedure to clean up after things. And let's exec USP delete orders. And IntelliSense is going to tell us that we need to add at order num equals, and let's make that 99999. That's what we did. and highlight that and execute it. One row affected, very nice. Select it again, and the bogus record that we added is now gone from the database. We are good to go. In exercise 9, we will once again create a simple parameterized stored procedure to update records based on parameterized criteria. For exercise 9, we're going to use as a parallel TAL 8 for this chapter, which says write a stored procedure in T-SQL that will change the price of an item with a given item number. So if we have the item number, update the price. How would you use this procedure to change the price of item AH74 to 26.95? Okay, well, let's start by structuring just a regular update. And part that would look like this. Update the item table, set price to, and we'll use it parameter at price, where item number is at item number. Okay, so that's the general form. We need to transform this into a stored procedure. So let's say create procedure, USP, let's call it change item price. And let's see here, we need to declare at item num. And if we look at the table definition, that's a char4, I believe. And we need at price. And I believe that is a decimal 62 as the following. There we go. So this should do it. Uh-oh. Parameter or variable at price has an invalid data type. What did I do incorrectly here? Oh, got to spell decimal correctly. Let's give that a shot. Ah, happiness. Okay, so now that we've got that, let's kind of test it here. Let's make a note of what the current price is for AH74. So let's select star from item and run it. And AH74 is currently $22.99. Let's come up here and make a note of that. $22.99 is the current price. Okay, and we want to see how we would change that to $26.95 using our stored procedure. And that's going to look something like this. And let's run it. One row affected. Let's select it. H74, now $26.95, previously $22.99. And if we want to put things back the way we found them, we just edit this line and run that procedure again. And let's select it out again. And we're back to where we started at $22.99, working perfectly. In exercise 10, we will create a query to select and display records using date arithmetic and the getDate function to report months elapsed between two dates. For exercise 10, we're using TAL 10A as our parallel problem, and that problem statement reads, TAL distributors would like to know the number of months between the current date and the order date of an order. Write a SQL statement in T-SQL that displays the order number and the number of months between the current date and the order date. The number of months should display as an integer. Okay, so we're going to have to work through some functions to get this working correctly. Let's start out with a fundamental query, a basic query here of just the order number and the order date from orders. Okay, so one of the things we're going to need to do is we're going to need to be able to determine the current date, and that can be returned using the getDate function in SQL Server. So you can see that at the time and date I'm running this, my computer clock is set to 2017, December 29th at 21:57, 11.160. Okay. All right. So we've got the getDate working. Now we need to figure out how to generate the difference between these two dates. Okay. And that we're going to generate using the dateDiff function. And we've used dateAdd before. DateDiff is going to give us the difference between two dates. And we need to specify that we want this in the unit of month. And that's going to give us the number of whole months elapsed between those two dates. And there we have the order number and 26 with no column name. So we should probably give that a column name. Call it months elapsed. And let's see, have we met our requirement? TAL distributors would like to know the number of months between the current date and the order date of an order. Write a SQL statement in T-SQL that displays the order number and number of months between the current date and the order date. The number of months should display as an integer, which it does. And maybe instead of months elapsed, we'll call this, since it was described as months between, as months between. And there we have it. Let's do a little sanity check right quick. Let's take a look separately at the order date and get date. And so it's saying that that's 26 months. And this was October of 2015. And add 26 months to that, it's saying is December of 2017. And that does seem to make sense. So I think we are there. Let's go ahead and clean up the extra fields that were not required. Quicker and easier than we thought. This concludes the lesson.